Hello everybody and welcome to today's lesson on factoring. Our objective for the day is we will factor polynomials by applying general patterns, and those patterns include the difference of perfect squares and perfect square trinomials. Now let's first remember what factoring actually is. Factoring is the decomposition of a polynomial into a product of prime factors. The decomposition, so we take it apart, of a polynomial into a product of prime factors. Now, I know you may have seen different ways of factoring. The way I always teach my students factoring is to look for the target sum and the target product. So the target sum in this first example is -5. Remember, the target sum is always the coefficient of our middle term. And the target product is the multiplication of the coefficient of the squared term, in this case 1, times the constant. 1 times 6 is 6. And we are now going to look for a number that, two numbers, excuse me, that if we multiply them, we get the target product, and if we add them, we get the target sum. In other words, we look for factors of the number 6 that when we add them give us -5, and in this case, the answer are -2 and -3. So taking those numbers, we can now write our factored form, x minus 2 times x minus 3. Is it coming back, you guys? Do you remember? Let's try the next one. The target sum is +7. The target product is -30. We are looking for numbers, factors of 30, that give us 7 added together, and the answer is 10 and -3. If we multiply 10 by -3, we get -30. If we add 10 and -3, we get 7. So this time the factored form is x plus 10 times x minus 3. On to our next example. Target sum is -4. Target product is -5. So we are now looking for a negative and a positive number again to give us -5 as a product and -4 as a sum. And the answer is -5 and 1. Our factored form is x minus 5 times x plus 1. One thing that we need to always remember is that always check for a GCF first. When we look at our trinomial or binomial, we have to check that there is no GCF that is in all terms, because if there is, we have to take it out to simplify the terms that we're trying to factor. Always remember that. Looking at our first problem here, 2x squared plus 6x. What do the two terms have in common? Well, they have a 2 in common. 2 goes into both 2 and 6. And they also have an x in common. If we take that out and then write in parentheses what we have left of each term, the first term we have x left, and of the second term we have +3 left. If you want to check it, then you can go ahead and distribute the 2x back into the parentheses, and you will find out that you did the work right. Remember, distribution and factoring is actually going inverse directions. So distribution can always be a good check for factoring and vice versa. In our next example, if we look at the three terms, we see they don't all have an x, so we can't pull out an x, but all the numbers that we see are divisible by 3. In this case, we're going to take out the negative 3 to make the first term in the parentheses positive. And what's left inside is x squared minus 2x. Remember, we took out the negative sign. Negative times a negative is positive. Minus 5. Now we need to go ahead and see if we can factor the trinomial in parentheses any further. If we look at our target sum of -2 and our target product of -5, what are the factors of 5 or -5? None of those can actually be added up to 2 or -2. And this means that this trinomial in the parentheses is relatively prime. It's kind of like a prime number. They don't have any common factors. Let's move on to example number 6. And here we find that we do have a greatest common factor. We have the number 2, as well as x can come out, and that leaves us with x squared plus 3x minus 10 in our parentheses. This trinomial we now need to factor. The target sum is 3. The target product is -10. What are the numbers that work out to give us both target product and target sum? Those numbers are +5 and -2. So therefore our final answer, and don't forget the greatest common factor that you found out in the first step. That is part of our final solution. That stays on the outside, and we got 2x times x plus 5 times x minus 2. So always remember to look for a greatest common factor first. If you don't, and you start your factoring process, you will not get a fully factored answer. And what you will find then is that usually one of the factors in the parentheses still has something that can be pulled out. But it's way easier and it avoids any mistakes if you pull out the greatest common factor first. So after we have found the greatest common factor, sometimes we still have trinomials where a, in other words, the coefficient of our square term, is greater than 1, not just 1 as in the examples that we saw before. And then we have to factor by grouping. So after finding the GCF, if a is greater than 1, and that goes for our standard form of ax squared plus bx plus c, we need to do a technique that's called factor by grouping. Let's look at our first example. So we still look for our target sum, which is -13, and our target product, which is not 6, it's 5 times 6, right? Remember, it's always the product between A and C, +30, and that will give us the numbers -3 and -10. Now these two numbers are not the numbers that we put directly into our parentheses, like we have done in the examples before. Now we do a separate step, and we split our middle term. What do I mean by that? We rewrite our trinomial into a polynomial with 4 terms. And instead of writing negative 13x, we write negative 10x minus 3x plus 6. Now realize that this polynomial is still exactly the same, or it has exactly the same value as the trinomial above. All we did was we split the middle term. You should write that down too, because this is what we do in order to get 4 terms now. And those 4 terms we are now going to factor by grouping. So we're going to group the first 2 terms together and see what they have in common. 5x squared minus 10x. They have a 5 in common and an x. So what's left after is x minus 2. And then we're going to go ahead and also factor the next 2 terms as a group. Negative 3x plus 6 have no x in common but a negative 3. So what remains is x. And since we pulled out a negative number from the 6, we remain with negative 2. Now this is critical, and this is also a very helpful check. We need to see and we need to be sure that what's in the parentheses for both our factoring operations is the same. If this is the case, then we did the work correctly, and that also guides you a little bit to always find the parentheses in the back, the second ones, after you already have your first ones. So we now have a factored form, which is x minus 2, which is the parentheses that we already found twice, and another set of parentheses, and that will take all the leftovers. In other words, 5x minus 3. And this is a final factored form. Well done, you guys. Moving on to number 8, we find that our target sum is 19. Our target product, 3 times negative 14, is negative 42. And after looking around a little bit, that will give us the 2 numbers 21 and negative 2. We're now going to go ahead and split our middle term to get 3x squared plus 21x minus 2x minus 14. And again, realize that 21x minus 2x is really the same as 19x, right? Has the same value. So let's factor our 2 groups here. 3x squared plus 21x have 3x in common. X plus 7 remains. And negative 2x minus 14 have no x in common, just negative 2. And we get x. And again, taking a negative out from a negative now turns the number, makes it positive, x plus 7. So let's write our final factored form. X plus 7 times 3x minus 2. Here is your fully factored form. Now the next problem I'm going to ask you to do yourselves. Try it yourselves. Stop the video and do it yourselves, and then check your work and your answer with my answer. No cheating, alright? Hopefully you also got the same thing here. Our target sum is 5, target product is 6, which gives us the numbers 2 and 3. These ones we're going to use to split our middle term. So now we got 2x squared plus 3x plus 2x plus 3. We are going to factor the first set. The first set only has x in common, and in parentheses remain 2x plus 3. And then we look at our second group of terms, and they have nothing in common. Actually nothing, or in other words, The only thing we can factor out is a 1. And if that's the case, then we really have to do it. We have to take that 1 out. And we got 1 times the entire parentheses the way it was before, 2x plus 3. So our fully factored form is 2x plus 3 times x plus 1. So one last note on finding the factors of a number. In one of the previous examples, we had the number 42, and with numbers that get large or even larger than that, sometimes it can be a little difficult to make sure that we have found all the factors, and if we miss one of them, then we may come to the conclusion that the trinomial is not factorable, and then we miss an obvious answer. So here's a trick to make sure that we find all the factors of a number, and it helps us, as I said, because then we will not miss any numbers and come to the wrong conclusion. Using the 42 from the previous example, I'm going to write that 42 down, and I'm going to leave some space, and in the bottom I'm going to write 1, because 42 times 1 is 42. And then I keep going down from the 42 and up from the 1, and I keep meeting somewhere in the middle. The next factor of 42, if you want to start from the bottom or from the top, that is, either one works perfectly fine. We get 2, and 2 goes into 42 21 times. Then we have 3. 3 also goes into 42 14 times. 4 doesn't go, 5 doesn't go, 6 again goes into 42, and 6 goes into 42 7 times. Now let's connect the ones that we know are partners, that are pairs. 42 and 1, 21 and 2, 14 and 3, 7 and 6. This is called a factor rainbow. I'm sure you can guess why. And what happens here is we have found 4 pairs. We know that we have the numbers that belong together that give us the 42 as a result when we multiply them. And also by moving up from the 1 and down from the 42, we meet in the middle at the 6 and the 7. And we know between 6 and 7 there is no other natural number. So we have all the numbers that we needed. Just a little trick, you can put that in the left margin of your notes, and that might come in handy sometime in the future. Now go ahead and watch the second part of this tutorial.